Hi guys, let's talk about surface area and volume. So I got a question for you to start with, and tell me something. This is an octopus, obviously. So which has the greater surface area to volume ratio? This octopus or a whale? What do you think? I want you to think about that, because we're talking about the surface area over volume. Okay, so which has a greatest surface area to volume ratio? And what are the advantages or disadvantages of that? For example, more surface area to the same amount of volume, or less surface area to the same amount of volume. What do you think of the advantages or disadvantages of that for an animal? That's what I want you to think about. Our objectives for today: we want to explore the ratios of surface area to volume. That's one of the things we're going to look at. And the other one thing we're going to look at is how to maximize or minimize volume and surface area, depending on what we want more of or what we want less of. So we're going to look at that relationship between surface area and volume. Okay? Well, first of all, the surface area, let's say we have, we have a math teacher who is not very good at drawing things. But I think you kind of get the picture of what it is I'm trying to draw here. What we have here is a rectangular prism. You know that. It's got a rectangle here and a rectangle here. These are the two bases. These are the lateral sides. Okay? And so let's say this is the length. Okay, from here to here is the length. And this is the width. Okay? And from here to here, this is the height. Okay? So we got length, width, and height. Well, the surface area, total surface area, remember that you've got 6 sides here. For example, on your base here, this area here I'm shading here, okay? That base is length times height. That's a rectangle. And the area of that rectangle is length times height. So let's say length times height. And this area here, this side, okay, the right side, this is width times the height, okay? The height is the same here as it is over here. So you got width times height. And then this area at the top, okay, is width times length, or length times width. So you notice that you're multiplying length times width times height, and then length times height. Okay, length times height is your first one. Width times height is the next one. And then the last one is length times W. But that's only 3 sides of this prism, isn't it? You remember all 3 sides are the opposite sides? Like, for example, this is the front. The back side looks exactly like the front side, doesn't it? It's exactly the same measurements and everything. And so we take this whole sum of all 3 of these, and we multiply that by 2. Okay? And that's your total surface area of a rectangular prism. Okay? So on a rectangular prism, you have length, width, and height, and you multiply. So let's just see what I'm going to show you an example of what we're talking about. Let's suppose I have a rectangular prism, and the length equals 4 centimeters, and the height equals 7 centimeters, and the width equals 3 centimeters. That's a 7, by the way. Maybe I better put a little thing there through there. So, okay, now. So how do you do it? Now the easiest way, and I'm going to show you this because it's really, really a simple way to do this, okay? 4 times 7 is 28, right? That's the length times the height, right there. Okay? Plus 3 times 7 is 21. Plus The other two we didn't count yet. These two I didn't count together. 4 times 3 is 12. So you add those three together. 28 plus 12, that's 40, plus 21 is 61. But I've only counted 3 sides now, so I have to multiply that by 2. So what I've done here is I've followed this formula precisely. Width times height is 3 times 7 is 21. Length times width, okay, is 4 times 3, and that's 12. So I've taken those three, I've added them together, and that's 61. And now I multiply by 2. And so the total surface area of this rectangular prism that I've identified here is going to be 122 centimeters squared. Remember, even though we're dealing with a three-dimensional object, our total surface area is a squared centimeters squared because we're dealing with 3 sides or 4 sides or 6 sides, whatever like that. Okay? So, I'm sure you understand all of that completely. So let's talk about how to find the volume of that same one. And volume, okay. Volume of this rectangular, right rectangular prism is volume equals length times width times height. This is one of those things where surface area is a little more complicated than volume. Volume is pretty easy. So for this one here, it's 4 times 7 times 3. And 4 times 7 is 28. Well, let's do it this way. 3 times 7 is 21, and 4 times 21 is 84 centimeters cubed. So this up here, this is your total surface area. Down here, this is your volume. Your volume is cubed, your surface area is squared. So this is all for a right rectangular prism. You say, but Mr. Mistler, what if we have a cube? Well, I'm really glad you asked that question. Let's talk about a cube. Okay? A cube, as you know, is when you take a square and you extend it the same amount out this way, and so your side and side and side, your length, your width, and your height are all the same. That's what makes it a cube. Okay? So the total surface area, remember you have 6 sides on this cube. So your total surface area is 6 sides, and the area of each side is s times s, or s squared. So the surface area of a cube, okay, is pretty easy. It's 6 times s squared. And I think there's a test question recently about that, which many of you didn't get because you couldn't quite understand that. So what's the volume of a cube? Oh, you're going to love this one. The volume is s cubed. Where do you think that term cubed came from? From the volume of a cube. And let's suppose you have a cube with side length 7. Okay? So what do you mean? What's the length? What's the width? What's the height? They're all 7. Remember, it's a cube. Side, side, side. They're all 7. Okay? So we've got surface area equals 6 times 7 squared equals 6 times 49 equals 144. If you don't believe me, figure it out. Okay? So, and how many is that? I didn't put a units here, so let's just say units squared. I know a lot of you guys are real lazy about putting the units or units squared or units cubed. And remember, if this is not correct, you lose a half point on a quiz or a test. Okay, and then finally, let's look at the volume. The volume is 7 cubed equals 7 times 7 times 7 equals 49 times 7 equals, oops, sorry, my bad. My writing utensil is getting away from me. And 543. No, 343. My bad. I'm going to blame it on old age. Can I blame it on old age? Okay. So it's 343 units cubed. Okay? And that's how that works. And so now let's talk about a cereal box. You got two cereal boxes. Two cereal boxes. Okay? A is 4 times 5 times 8. Okay? Or 4 by 5 by 8. You say, well, which one's the length, which one's the height, which one's the width? It doesn't matter. Please, it doesn't matter. And B, cereal box B, is 2 times 8 times 10. So first of all, let's look at the total surface area. Remember, surface area, let's do it the quick way, equals 2 times length times width plus width times height plus height times length. Okay? And so we're going to do that real quickly here. 4 times 5 is 20. 5 times 8 is 40. And 4 times 8 is 32. So how did I do that? 4 times 5 is 20. 5 times 8 is 40. 4 times 8 is 32. So 2 times 32 plus 20 plus 40 equals 2 times 92 equals 184. Let's call that centimeters squared. Okay? And I'm going to change color here so we don't get too confused. This 2 times 8 is 16. 8 times 10 is 80. And 2 times 10 is 20. So you get 20 plus 80 plus 16 times 2 equals, let's see, 116 times 2 equals 232 centimeters squared. Now, obviously B has more surface area. More surface area. Let's look at volume. And I'm going to change colors again. And the volume is 4 times 5 times 8. 4 times 5 is 20 times 8 equals 160 units. Oops. Cubed. Okay, units cubed. Sorry about that. Ran out of room over there. There you go. And so now, what about this other one? This is 2 times 8 times 10. 2 times 8 times 10 equals 16 times 10 equals 160. I said centimeters cubed. It's supposed to be centimeters cubed, isn't it? Make that centimeters. Okay, so 160 centimeters. Oh my goodness, look at here. They have exactly the same volume, don't they? So this one has more surface area. This one has less surface area. So if you're selling cereal and you have the same volume, the same amount of cereal in both boxes, so which one do you want? Do you want the one with more surface area? Because remember, if it's bigger surface area, this is the front of this is 8 by 10. There's more places to advertise your product. Or less surface area, that means less material. Which one is better? Which one's worse? That's one of the things you have to think about. Thanks for joining me.